Welcome back. In the last few lectures, we explored custom aggregation functions and grouped transformations. Before moving on to adding and updating columns, it's essential to understand how to use apply for row level transformations. This lecture will focus on creating derived columns using apply with practical real world examples. Why we need to use apply method for row level transformations? When it comes to the apply method, it allows us to apply custom logic to each row in a data frame. It's particularly useful for creating derived metrics or calculations. 2. Handling complex conditions or business rules. 3. Applying transformations when built-in Pandas operations don't suffice. Soon you will be seeing the examples and you will understand the importance of apply method on top of Pandas data frames. Let's start with Toyota sales dataset. We have been using this for quite some time. First, let me run this to create a data frame by name Toyota sales data. Now, let me run this to get first 10 records. You can see this dataset have columns like sale amount and commission percentage. We'll be using these columns to explore apply method. For each and every record, you can see the sale amount, which means the car model Tundra is sold on this date for this amount. On top of sale amount, we also have commission percentage or commission underscore PCT. The values are in the range of 0 to 1 and they are decimal. It means the commission percentage for this transaction is nothing but 5%. Also, when it comes to commission underscore PCT, you can see there are null values. We need to make sure we have special attention towards these null values. We will see how to handle these null values while dealing with commission percentage to compute commission amount. We'll actually compute commission amount using apply method. You will understand what I'm talking about very soon. Let's start by calculating the commission amount for each row based on sale amount and commission percentage. Initially, we want to handle null values to demonstrate the potential issues. Once we go through the initial example, then we'll actually get into the details about how to handle null values. Now, here I'll be creating a new function. The function name is nothing but calculate commission. We'll be passing each sale transaction as argument to this. We'll be using apply to pass each transaction. You will understand what I'm talking about very soon. Here we'll be returning the product of sale amount multiplied by commission percentage. Now let's run this. Now the function is created. We should be able to invoke this for each and every record without using for loop by leveraging apply. Before getting into the usage of apply, let's look at the help and then we'll take it further. In this case, I'm saying help, then Toyota sales data, then apply. Apply is the method that is available on top of DataFrame. Now, if you look at the help, you will understand more details about this function. Actually, we should term it as method. You can see apply is method available on top of DataFrame. It takes multiple arguments. You can specify the function as first argument. After that, you can use other keyword arguments that are available. One of the most important argument is nothing but axis. Let's understand what axis is about. When it comes to the objects that are passed to this function, they are nothing but series objects whose index is either data frame's index or the data frame's columns. If you say axis is equal to 0, that means data frame's index. Otherwise, it is nothing but columns. You can see the details here. It is nothing but 0 or index or 1 or columns. The default is 0. It will apply function to each column. If it is 1, it will apply function to each row. So in case if you wanted to apply the function for each row, you have to specify axis equal to columns or axis equal to 1. If you specify 0, then it will apply based on this index. Keep in mind, when it comes to the Pandas data frame, each row will have an index value. This is the index column. These are the values. So by default, it will try to apply based on these, not the column names. If you wanted to apply any transformation at row level, then you have to specify axis equal to 1 or axis equal to columns. That being said, now let me scroll down here. Let me copy this. In this case, for each record, we have to multiply the commission percentage with sale amount. There's a function already. The function is nothing but this one, calculate commission. Hence, we can say calculate commission, then axis equal to 1. Now let's run this. You can see the outcome here. If you want, you can also use lambda functions. Let me copy this. Let me paste. In place of calculate commission, I can say lambda, then sale, then sale underscore amount multiplied by sale commission percentage. Now let me run this. Even this one worked as per the expectations. The calculate commission function multiplies sale amount by commission percentage to compute commission amount. You can see the commission amount here. However, the axis equal to 1 argument is required. It ensures the function is applied to each row. As commission percentage contains null values, the calculation will result in null commission amount. You can see examples here. Let's enhance the function to handle nulls by assuming a default commission percentage of 0 when commission percentage is missing. The way we can handle is like this. First, let me copy the function logic here. Then paste in the new cell. Here, let me define a new variable by name commission underscore PCT. Then I'll say sale of commission underscore PCT if pd dot not null. So pandas have a special function called as not null. You should be able to specify the column name here. Let me say sale of commission percentage. So if it is not null, then we are picking up the commission percentage itself. Otherwise, we wanted to pick 0. For that, we should be able to say else 0. Now here, we have to replace this with commission percentage. If it is not null, then it will be multiplied with that value. If it is null, it will be multiplied with 0. Now let me run this. It ran successfully. Let me pick this code once again to demonstrate the usage of apply. Let me paste here. Then let me run this. Now you see when it comes to commission amount, it is displaying as 0 rather than showing null values or NaNs. In case if you wanted to round these values to 2 decimals rather than 4 decimals, here you should be able to use round function. Then as part of the second argument, you can say 2. Now let me run this and then let me run this. You can see the outcome as per the expectations. When it comes to this enhanced calculate commission function, it checks if commission percentage is null and assigns a default value of 0 if it is. You can see the logic here. This prevents null values in the resulting commission amount columns. You can see the outcome to confirm that there are no null values in the results. Now let's enhance what we have learned so far. Suppose we wanted to flag rows with high commission amounts. When I say high commission amounts, I am talking about those sales where commission amount is greater than 1000. Here, whatever I have highlighted is nothing but high commission because it is greater than 1000. But this is not high commission because it is less than 1000. We'll add a high commission column that marks such rows as true or false. Now let me define another function. I'm saying def flag high commission. Again, sale will be passed as argument. Now let me say return, then sale commission underscore amount greater than 1000. Keep in mind our original data frame doesn't have commission amount column. First we need to make sure the data frame is updated with commission amount. Then on top of it we should be able to use this function to flag high commission amounts. Before running this, what I'll be doing is I'll be saying Toyota sales data, then commission amount, then equal to, let me pick this piece of code. Let me paste here. Let me run this. Now let me preview the data using this. You can see the outcome. A new column is added. The column name is nothing but commission amount. However, it is a little bit clumsy. Let me drop a few of the columns. I would like to drop sale date and sale status. For that, I should be able to use drop. On top of data frame, I can say drop. Then I should be able to specify multiple columns in the form of list. The first column which I wanted to drop is nothing but sale underscore date. The second column is nothing but sale underscore status. Here I have to specify axis equal to 1. Otherwise it will try to remove the rows by index values. But we wanted to drop the columns, hence we have to specify axis equal to 1 for drop. Now let me run this. You can see the outcome. There is no sale date or sale status, but we can see commission amount as per the expectations. Now let me make sure I drop the columns from the original data frame. For that, what I should be able to do is I should be able to copy this, then paste here. Then let me rename the data frame, or let me reset the data frame by assigning to the same name. Here I'm saying Toyota sales data equal to Toyota sales data dot drop, which means the columns will be dropped from the original data frame itself. You should be able to preview by saying dot head of 10. It is as per the expectations. Now we wanted to apply flag high commission on top of this updated data frame. So now I should be able to say Toyota sales data, then dot apply. Before using this, we have to run this. I have run this. The function is created. Hence, I should be able to say dot apply, then flag high commission, then comma axis equal to 1. Now let me run this. You can see the outcome here. It is saying true or false depending upon whether the commission is really high or not. Now I would like to add a new column to this data frame. Hence, I should be able to say Toyota sales data, then high underscore commission, then equal to, then Toyota sales data dot apply, then function with axis equal to 1. Now the data frame is updated with the additional column. We should be able to validate by saying Toyota sales data dot head. You can see the outcome here. There is a new field by name high commission, and it is saying true or false depending upon the commission amount. Let me specify 20 here so that we can preview first 20 records. You can see as this is less than 1000, it is saying false. Even for 0, it is saying false. But for those records where commission amount is greater than 1000, it is saying true. When it comes to the flag high commission function, it checks if commission amount exceeds 1000 and returns a boolean value. It is then used to create the high commission column. Now let's recap what we have covered in this lecture. We have used apply method for row level transformations to calculate commission amount. 2, we have enhanced the function to handle null values gracefully. Also 3, we created a flag column to identify rows meeting specific criteria. The column name is nothing but high commission. In this lecture, you learned how to use apply method for row level transformations with practical examples. Now we are ready to move back to the original plan and explore how to add and update columns systematically. See you in the next lecture.